According to Kohlrausch law, the conductivity of an ion is independent of its compound. For example, H plus, whatever the conductivity of H plus is there, it will be same from HCl or CH3COOH. HCl may be a stronger electrolyte, acetic acid is a weak electrolyte, but the contribution from H plus will be same in both the cases. The contribution of an ion in view of its conductivity will be same whatever the compound is. It may be a strong electrolyte or it may be a weak electrolyte. So in other words, you can say always an ion gives its conductivity fixed irrespective of the nature of the compound it is having. Okay, now if the H plus is present in this or this, or you take sodium plus ion, if the sodium is present in sodium hydroxide, if it is present in the CH3COONA, whatever it is, the sodium contribution is going to be fixed. This is known as Kohlrausch law. This law is very much useful in calculating the conductivity of weak electrolytes. For example, lambda infinity, or you can say lambda 0, lambda naught or lambda infinity, both meaning is same. Infinity means infinity dilution. Okay, now 0 means 0 dilution. Okay, now the meaning is same, lambda infinity or lambda 0, both meaning is same. For example, CH3COOH, if you want to know, it is the addition of lambda acetate ion and lambda H plus ion. By adding these two, you will be getting the acetic acid one. It is a weak electrolyte, but if you know this value and this value, you will get this one. Lambda infinity or lambda naught of HCN is equal to lambda naught of H plus plus lambda naught of Cn minus. All these are weak electrolytes. That's why I am giving you these only. Lambda infinity of NH4OH, ammonium hydroxide, is equal to lambda infinity of NH4 plus OH minus. Lambda infinity of CH3COONA is X. Lambda infinity of CH3COOH is to be calculated, and two more values are given. Lambda infinity of NaOH is some Y. Lambda infinity of HCl is equal to Z. Okay, units will be same. Okay, now Siemens centimeter square per mole. I am not mentioning the units. Siemens centimeter square per mole, that is the unit. So what you need to understand from this is asking for the lambda infinity of CH3COOH. Lambda infinity of CH3COOH means you need CH3COO minus ions and H plus ions. CH3COO minus ions you can get from this one. So add this value, lambda infinity of CH3COONA. Good. You got CH3COO minus part. You need now H plus part. H plus you can get from lambda infinity of HCl. So add lambda infinity of HCl. Job done. Good. So from here CH3COO, from here H you got. But extra we have NaCl. Okay, now let us say this is NaCl. Sorry, NaCl. Now you need to subtract lambda infinity of NaCl. Why? You need only acetate ion and H plus ion. Here we have acetate ion and sodium ion. Here we have H plus ion and Cl minus ion. When you are adding these two, of course you are getting CH3COO and HCH3COH, but extra we are taking NaCl. These two must be subtracted. So from the given values you can see, from the given values you can check what is given here. Okay, this I am mentioning again, you see, minus lambda infinity of NaCl, sodium chloride. CH3COO is given as X Siemens centimeter square per mole. Then HCl is given Z, X plus Z. Then NaCl is given as Y, so minus Y. X plus Z minus Y will be the acetic acid's equivalent conductivity. That you can calculate by this one. So this is a very regular question in all entrance examination, and even in board examination also you can expect this question. In this question, lambda infinity of ammonium hydroxide is asked, and given are lambda infinity of NH4Cl, lambda infinity of NaOH, and lambda infinity of NaCl. So according to the concept, according to the Kohlrausch law, lambda infinity of NH4OH is equal to, you need to take a compound in which NH4 is present, that is there. So lambda infinity of NH4Cl, and you need OH. OH is present in sodium hydroxide, so you can take lambda infinity of sodium hydroxide. All these are the strong electrolytes. Strong electrolytes values can be known to us and already given to us in the question. So NH4OH is there, and extra we have NaCl. So just subtract that NaCl value. So A plus B minus C. This is A, this is B, and this is C. A plus B minus C will be your answer. Let us see this question. Lambda infinity of hydrogen cyanide is asked, and there are plenty of values mentioned. Lambda of HCl, lambda of NaCN, lambda of KCN, lambda of HNO3, lambda of NaCl, and lambda infinity of KCl, NaNO3, KNO3. All these values are there. So what are the possibilities? How many values you can use? Okay, so let us see. Lambda infinity of HCN means what are the possibilities? Okay, I repeat, hydrogen. So you take a hydrogen containing compound. For example, if you are taking lambda infinity of HCl. So hydrogen is, you obtain hydrogen. Plus now you need cyanide. Cyanide is present in NaCN or KCN. You take any one. Lambda infinity of NaCN I am taking, good. So you got cyanide. HCN you got. Extra is NaCl. So subtract it. Lambda infinity of NaCl you are subtracting. Otherwise you see, lambda infinity of HCN you can calculate by taking lambda infinity of HCl plus, instead of NaCN I am taking KCN, lambda infinity of KCN. HCN came, KCl is extra, lambda infinity of KCl, that is also given to you value. So you can use this formula also. Lambda infinity of HCN is equal to lambda infinity of HCl plus KCN minus KCl. Just to see what I am doing here. Hydrogen, cyanide I am adding. K and Cl I am subtracting because I want HCN only. When you are taking this compound, you are taking H and Cl both. When you are taking this compound, you are taking K and cyanide both. But you want hydrogen and cyanide only. So extra is KCl, that you are subtracting. One more value you see. One more possibility. If you want lambda infinity of HCN, let us take lambda infinity of HNO3, if that is given in the value. Hydrogen you got. Okay, then HNO3 and NaCN if you take lambda infinity of NaCN. Fine. H and Cn you got. Extra NaNO3. Subtract lambda infinity of NaNO3. You can do even by using potassium also. Okay, now if you are using in this place of this HNO3 you are using here, if in place of NaCN if you are using KCN, here if you are using KCN you use here KNO3, or if you are using sodium here, sodium. This is the wonderful concept known as Kohlrausch law. Very, very, very important.